The twin spacecraft, Voyager 1 and Voyager 2, have been exploring space for 45 years, far surpassing their original mission of just 5 years. They continue to send data back to Earth, and scientists believe communication with them will last until about 2025. However, questions arise as to whether they'll make any more discoveries in the time they have left, and if their journey can continue. Hello, and welcome to Z. Please don't forget to subscribe and hit the bell icon. The Voyager missions were initially aimed at exploring Jupiter, Saturn, and their moons, capturing images that provided new insights. For the first time, scientists could clearly see the surfaces of Saturn's moons, which were previously just bright spots. One significant discovery was Saturn's moon Enceladus, which appeared smooth and free of craters, suggesting geological activity. Today, we know this smoothness is caused by cryovolcanism, but it was an astonishing discovery in the 1970s. Voyager also dramatically changed our understanding of Jupiter's moon Io. Once thought to be a frozen, rocky world, the probes revealed a volcanic landscape with massive eruptions, the first active volcanoes seen outside of Earth. In addition, the Voyagers discovered Jupiter's radiation belts and its previously unseen planetary rings, with Voyager 1 detecting them in 1979, followed by Voyager 2 capturing more detailed images. Saturn's famous rings were also observed, consisting of countless small particles. These early observations laid the groundwork for future missions like NASA's Cassini. Although the mission was originally expected to last only 5 years, a rare planetary alignment extended its lifespan. Voyager 2 went on to explore Uranus and Neptune, while Voyager 1 took a closer look at Jupiter's moons. The twin spacecraft, weighing 773 kilograms each, carried 105 kilograms of scientific instruments, including cameras that, despite their small memory compared to today's standards, transmitted hundreds of thousands of images. The key to the Voyager's longevity is their power source: 3 radioisotope thermoelectric generators powered by plutonium-238. As the isotope decays, the power decreases, with Voyager 1's output dropping by 57% since launch. To conserve energy, some systems were turned off, but the spacecraft still provide valuable data on the boundary of the heliosphere and interstellar space. In 2022, Voyager 1 experienced an issue when its attitude control system began sending incorrect data, complicating its orientation in space. Due to the vast distance, signals take 20.5 hours to reach Earth, making communication slow and difficult. Despite these obstacles, the Voyagers continue traveling beyond the Sun's influence. In about 20,000 years, they will pass through the Oort cloud, a distant region filled with comets and icy debris. After 500 million years, they will have completed one orbit around the Milky Way's center. Even after we lose contact, they will continue their silent journey through space. Voyager 1 is heading toward the constellation Ophiuchus, and Voyager 2 toward Sagittarius. Each carries a golden record, a time capsule for any potential extraterrestrial civilizations. These records contain images, sounds, and information about humanity and Earth, designed to last billions of years. Even after the Milky Way collides with the Andromeda Galaxy, these records may endure as the final proof of human existence. The Voyagers represent more than scientific exploration. They are symbols of our curiosity and drive to explore the universe, destined to drift through space long after we are gone. The Voyager mission, one of the most significant space exploration endeavors, has fundamentally changed our understanding of the universe. Launched in 1977 by NASA, the twin spacecraft, Voyager 1 and Voyager 2, were originally designed to explore the outer planets of our solar system. However, they have gone far beyond their original objectives, continuing to send valuable data back to Earth and raising profound questions about the limits of our capacity to see into space. These spacecraft have allowed humanity to peer deeper into space and time, but their journeys also highlight the physical and technological barriers to observing the cosmos. The Voyager mission. Origins and achievements. The primary mission of the Voyager spacecraft was to explore the outer planets, Jupiter, Saturn, Uranus, and Neptune, along with their moons. Both Voyager 1 and Voyager 2 were equipped with a suite of scientific instruments, including cameras, magnetometers, and plasma detectors. The two spacecraft successfully captured detailed images of the gas giants and their moons, revealing new phenomena such as volcanic activity on Jupiter's moon Io and geysers on Neptune's moon Triton. Voyager 1, currently the farthest human-made object from Earth, has crossed into interstellar space, the region beyond the influence of our sun's solar wind, in 2012. Voyager 2 followed suit in 2018. This milestone marked humanity's first step into the vastness beyond our solar system, a region filled with the material ejected by dying stars. This leap allowed scientists to study the boundaries of the heliosphere, the bubble-like region of space dominated by the solar wind. How far into space can we see? In terms of how far we can physically see into space, the term see needs to be clarified. Through spacecraft like Voyager, humanity can gather data about space from a relatively close proximity to certain celestial objects. The Voyager mission itself, however, is not about literal seeing through telescopic lenses. Instead, it is about measuring other forms of radiation and particles, providing indirect information about the surroundings. The spacecraft have no ability to take pictures at their current distances, as the vastness of interstellar space contains mostly emptiness and sparse particles. When it comes to actual visual observation, our most powerful tool is not Voyager, but the Hubble Space Telescope, and more recently, the James Webb Space Telescope, JWST. These space-based observatories can see light from distant stars and galaxies billions of light years away. For example, the Hubble Space Telescope has captured images of galaxies as far as 13.4 billion light years away, near the edge of the observable universe. This distance represents a vast swath of cosmic history, allowing scientists to look back in time to just a few 100 million years after the Big Bang. However, the Voyager spacecraft have expanded our understanding of space beyond light. Voyager's instruments have measured cosmic rays, plasma waves, and magnetic fields, data that helps scientists comprehend the nature of interstellar space. Though that they cannot see in the visual sense, they provide an invaluable window into the conditions that lie far beyond the reach of light-based observation tools like telescopes. The limits of space exploration. While the Voyager's ongoing mission offers exciting insights, there are practical limits to how far we can see into space. The universe is not only vast, but also expanding at an accelerating rate. Even with the fastest spacecraft, like Voyager 1, moving at over 17 kilometers per second, traveling to the nearest star system, Alpha Centauri, would take tens of thousands of years. Light, the fastest thing in the universe, still takes over 4 years to travel from Alpha Centauri to Earth. Moreover, as the Voyagers continue their journeys, the signals they send back to Earth grow weaker and more difficult to interpret. NASA engineers must carefully manage the spacecraft's power, which is generated by a slowly decaying plutonium source. At some point, likely in the late 2020s, both Voyager 1 and Voyager 2 will cease to function, cutting off their communication with Earth. Even our most advanced telescopes are limited in their ability to observe beyond the observable universe. Due to the finite speed of light, there is a cosmic horizon beyond which we cannot see, because the light from those regions has not had enough time to reach Earth since the universe began. This is known as the cosmic light horizon, currently estimated at about 46 billion light years. Conclusion: a glimpse into the infinite. The Voyager mission has provided an unprecedented view of our solar system and the interstellar medium. While the spacecraft continue to push the boundaries of human knowledge, the limits of what we can see in space, whether through telescopes or data-collecting probes, remind us of the vast unknowns that remain.